Very good evening. A warm welcome to one and all present here. I welcome you all on behalf of IITE. Today, the technical guest lecture on the topic energy reduction innovation by Engineer K. Balamurugan. I would like to introduce our speaker. I just go through his profile. He is a BE, Electrical and Electronics Engineering. He has completed in SRM University, Chennai, and also he has done his MBA Operations Research from Madurai Kamaraj University. Mr. Balamurugan has undergone training in AOTS training in Japan, understanding Japanese culture, special training, and understanding overall shop floor operations in the year 2005. And also again, he has undergone training in Japan, Amobia Management. In 2008, he has handled the machine maintenance facility, mold maintenance, paint shop, production operations, projects, and he is with currently he is a general manager of maintenance with Toyota Gosei South India Private Limited, Bengaluru. Earlier, he also worked with Bright Automotive Plastic Industry, Pondicherry. He is having close to 24 years of experience. He has handled maintenance and facility enhancement, new customer demands, budget preparations, machinery procurement, installation, facility expansion, till start of production. Maintaining his other responsibilities include maintaining facility and equipments in site of readiness to avoid line stop, ensuring safety in production facility, periodic training to team members and safety. And also he has done IATF and OHS system establishments. And some of his key achievements are he has established one safety role model plant in the field of plant construction safety, Toyota Motor Asia Pacific. Also established strong safety management systems at Toyota Suppliers Safety Cluster Model Role Model in Bangalore region. And also he has the skill development in the built-in quality concepts, injection molding machine to achieve no defect condition from machines. Also established the power purchase agreement, the green power purchase with external agencies, and achieved 85% of green power purchase for the financial year 2019. Also established Energy Ubaya to have power reduction awareness for employees and bringing down CO2 consumption as a stringent point of view. Also established power purchase agreement with the discounted energy rate scheme as BESCOM and achieved 100% green energy from April 2022. A warm welcome to Engineer Balamurugan. Please go ahead, sir. Over to Engineer Balamurugan. We are eager to listen to your session. Thank you, sir.
Thank you, sir. Thank you, Prakasan, for your simple introduction. And let me go for the presentation or the session. It is just what we are doing at Toyota Gosei at Bangalore. Just I am sharing to our colleagues so that they can implement at their shop floor. There are few concepts what we learned from Toyota and Toyota Gosei, so that it will be useful for any manufacturing sector. Now I'll go for my presentation. My screen is visible, sir?
Yeah, visible, sir.
Yes. Okay. It is a seminar on energy reduction, just an idea more than innovation or the viewpoint, what everybody can think about it. And as an overall agenda, I'll be covering the background, what is the global environment risk, the current scenario, and approach towards environment reduction or energy reduction, innovation activity, understanding on the viewpoint, and also the future roadmap. And with respect to energy reduction and management system, energy monitoring and muda control, supply, consumption and conversion viewpoint, which will be described in detail in the coming slides. And with respect to supply, renewable management, consumption on the ABC machine classification and on the conversion with respect to utilities like compressor, chiller management for CO2 reduction. So this will be the major areas that I'll be focusing. Sir, 1 second, my screen is little issues. Yeah, with respect to the current scenario as a world, as a global risk, the World Economic Forum, which is conducted in 2018, it is found more than 59% of the global risk or environmental risk. It may be extreme weather, natural disaster, biodiversity loss, and ecosystem collapse, and failure of climate change mitigation and adaptation, and also man-made environmental disasters. If you see the overall projected global temperature, which is by 2100, if you are not acting on the policies, what going to happen? This will be the minimum and max temperature which may go up. And based upon the current policies without PACC, Pacific Asia climate change, this will be the min and max temperature. And based upon the policies, if we adopt, the minimum and maximum temperature will be 2.4 and 2.7. So we are the people that need to change, and we need to be in line with government policies and world policies related to CO2 reduction, and also the relative corporate policies. So the environmental risks are becoming more prominent due to the climate change. And if you go through the global anthropogenic CO2 emissions, the quantitative information which is on methane and the nitrogen oxide emission, which is between 1850 to 1970, is limited. And you can see how it is going up, and the related gigatons of CO2 emissions, which is also in the increasing trend. And also how globally the Earth is going to be current and the future by between 2081 to 2100 with as indicated in the earlier side, 4 to 4.1 degrees centigrade from the current average temperature. So the means year on year the Earth temperature is increasing due to CO2 emission. And due to this, as the impact is the loss of habitat, flood issues. Actually, we have seen in the Bangalore in the recent times what rains we got, and if you see on the Mysore road also what floods we are experiencing. And inside the Techno Park also we had a lot of challenges where the first time the water has gone up to the pit and even the factory level. This is the first time we have seen in 23 years of history. These are all due to the climate change that is happening, and also the drought issues and water scarcity. So this climate change due to CO2 emission causes severe threat to the environment, which we are facing, and which we can see on our daily activities. And as per the Paris Agreement, against the action against the climate change, that is in 2015, where 190 countries participated, as our Prime Minister, Mr. Narendra Modi ji, has also been participated, and he has given a very clear pledge as the COP21 pledge in Paris Climate Summit. India need to reduce 33 or 35% of reduction by 2030 on the CO2 compared to 2005 results, and we are going in the right path as a government and also as a corporate policies. And as an Indian scenario of energy usage between financial year 20 to 21, almost 11,58,310 is the gigawatt consumption. And if you see as an industry, we are constituting 42% of the total consumption. And this is the energy generation capacity in India on thermal and also renewable. Still the thermal is on the higher side, and the renewable is still yet to go up. And as an India's activities on green energy, India wants to be the world's largest renewable energy expansion, that is by 175 gigawatt by 2022 end. And as on date, yes, we are with 105 gigawatt, and the policies is going towards it. And I think we are going to reach 175 gigawatt on renewable energy. With respect to the corporate policies like what TG we have, currently we are in the 7th Environment Action Plan, that is between 2021 to 2025, where it focuses mainly on use of energy that does not emit CO2, recycling of water and waste materials, and development of employees who can contribute to environmental protection. So all our policies are directed towards that, and our actions are towards this 7th Environment Action Plan. And every company will have such policies, and we need to adhere it so that we will not have a bigger impact for the future generations. And Toyota Gose has a long-term new challenges to save the earth for future generations. And this is just an like intimation or awareness, like how TGSIN is having the power consumption. This is in lakhs, that is 12,20,000 units per month. It is again a bigger units in a scale, being inside being Toyota Technopark, and we are the highest consumers. And we have 3 plants where we have substation A, E, and F, and the distribution of this 12,20,000 units is being shown here. This is just for an information. And as an energy reduction, as a background, we need to establish a level up and process of energy management system. This is towards the ERI reduction and utilizing ERI thinking way for MUDA elimination. ERI is energy reduction innovation. Energy reduction to energy reduction innovation is lean as much as possible or skews as much as possible the ideas and implement it. And the first priority is process innovation, and second priority is product innovation, what TG and TGSIN focuses. And in that, the main is, as a process, energy is one of the area, like we need to do the reduction in energy cost. When you see as a production cost, the material cost, labor cost, and energy cost, these are all the 3 factors. With respect to material and labor, this is a very big challenge, as the material is controlled by customer, and the labor, either we need to go for automation with investment or the salary of every year. But as an energy, there is a huge scope for reduction, and it is easy to do. Hence, we need to focus on energy reduction. And whatever the cost, which case is more profit, like in case of energy, where if we do the kaizens, we can get more profit. We need to focus and we need to adapt and implement so that we can achieve the results at the earliest. Energy reduction innovation is the base to achieve 2030 CO2 reduction target based upon the government policies and the corporate policies. There we have a 3-pillar approach with basically the human development and strategy as a base, as a consciousness thinking. The goal is to achieve by 2030 2% of reduction minimum per year, mainly on consumption and conversion. Consumption is to reduce, conversion is to improve the efficiency, and the supply is through the external sources, either going for renewable energy or having an internal source of renewable energy. I will explain the consumption, conversion, and supply in detail in the coming slides. The thinking way for CO2 reduction is, as I told, the 3-pillar approach, and with a basic management of PDC approach to have a continuous improvement in our activities. And as a viewpoint, applicable area is 3 areas: consumption, conversion, and supply. Consumption is applicable for all production, utility, logistics, and also to office. Conversion, except office, the other 3 areas is applicable. And supply is applicable for all the 4 areas. It is just a department that has been described here, but it is almost a company can have a classifications and they can cover it. And ERI thinking way for CO2 reduction can only be achieved through PDC approach. This is the step involved in a systematic approach involved to establish this activity of ERI. First step is preparation. We call then plan, do, and check, act. As a preparation, the first is base establishment. Here, the policy, target setting, organization, VOBA establishment, and echo mind is very key. This is the base. With this base, then the monitoring analysis comes as a step 2, where it has a data, monitoring, breakdown of machine data, cost analysis of each data. Then, based upon this data, a target setting and kada is challenge. Identification need to be done. Target setting on each line on consumption and conversion, and also Midori idea generation and Kaizen identification based on viewpoint. And the evaluation of the result is evaluation system, establishment at Gemba, KPI evaluation, audit, result analysis, and updation to top management. And standardization is basically sustenance after audits, is again a policy review, objective and target revision, corrective action, and preventive action. So this is the basic steps that been established at TGSIN to have an effective energy management system. So we call a systematic EMS approach required for CO2 reduction. First, if you go as a base establishment, a company should have a policy where how the CO2 is being addressed. That comes, any actions comes as a top management direction and top-down approach. Your policy should be made clear. Then have an objective and target setting, considering 2030 or 2050 challenges based on corporate policies, government policies, and also our customer also we need to take into account, because we should be in line with customer and corporate and government. So objectives and targets should be in line with that, and form an organization to effective implementation of this activity, and also have an OBOA establishment, and have a human development and motivation by training. So strong base setting is the key to achieve CO2 reduction. So the base setting is key point. Next is monitoring and analysis. Monitoring means we need to have an energy monitoring data visualization. However, today many companies have come with digitalization. We are in the process of digitalization now. After establishing and showing some improvements on these activities, by end of this year, we'll be totally digitalized on energy with respect to the unit per kg, whatever we produce at the shop floor. So first step is visualize your data as overall data and have a daily monitoring record. Then shop-wise have a monitoring record, so that where to focus, that will be the key point. That is the breakdown of whatever we have the main reading. So energy monitoring is a vital step to grasp the real-time issue. Based on the monitoring, we need to have a target setting. So based upon that, set the target like 5% of tons of CO2 from the base target. In that, consumption reduced to 2% and on conversion 3%. Then have an area where need to focus on which process and which equipment. On consumption side, use only need, and on the conversion side, we should say supply only use. So these are the key words that we need to have in mind on consumption and conversion. And pick up the kadai with consumption and conversion. So there are 7 viewpoints on consumption, 6 viewpoints on conversion, and actually 2 viewpoints on supply. So this we need to have a clear thinking on the viewpoint and implement it in the shop floor, or find the NG points in the shop floor. Consumption is, example is fixed to variable. Conversion is use high efficiency equipments. Supply or supply is use of green power or green energy, either by internal having rooftop solar or through any OPEX models. So have a target setting as 100%. Then month on month have the reduction on whatever the ideas generated, and again have a PDC approach on this. So now we will go on the supply
Can you
portion.
please go to the previous slide and explain that the functions, because I couldn't read that left hand side portion of your slide. It's this one, allocate target to all related functions.
Yes, allocate target means process.
No, I don't want to know that. I want to know the boxes. I can't read them.
Okay. These boxes you want to see.
Yeah, I want to.
Like
I want you to
injection
read them
molding,
for
paint.
us.
Okay, injection molding, paint shop, office. Break down the production process into like molding process, tear milling process, vibration welding process, so that in each process, find out where you can have the CO2 reduction. And with respect to equipment, you can have chiller, cooling tower, in which equipment you can have a conversion factors. So this is breakdown of each equipment or each line you can call. Any of this detailed slide I will share you once I complete the presentation.
Thank you.
Now I'll touch upon the supply portion. Supply portion is the external, is what we call, or internal on the renewable energy. The energy reduction thinking way for CO2 reduction can only be achieved through the PDC approach. This is the base. And just everybody should know first about our electricity bill. I think in our company also I used to tell, first we should know what is our electricity bill. I am not going to detail, but every one of us should know what is that we pay. Example, 2,710 rupees if I am paying, how it is being charged, either as a demand charges or at a unit price, or what is this FAC, fuel adjustment charges we call, and what is the tax, and what is the variations happening across every year, that we should know. Then also we should understand about the bill, what is being produced by BESCOM to the companies. First know about our personal house bill. This is just a thinking or viewpoint. This is a BESCOM price as a Toyota Technopark. This is we have captured just last 20 years. We started with almost 3 rupees 80 paisa, and now it has gone up to, you can see what is the price, it has gone up. And this is not going to reduce. So the key factor is how we are going to reduce. One is consumption and have an energy efficient equipments, and how we are going to have a green energy. In future, the green energy also may be with a higher price, but CO2 reduction is the key point. So consumption and conversion will be a key factor that we need to focus. And as a Technopark, this is again year on year. The previous slide, what I showed is the BESCOM bill directly coming to Toyota Technopark. But since there are many companies inside Toyota Technopark, the other cost will be add up, and this is the cost year on year. And if you can see in the last 2019 and 20, we are with a reduced price because we had a PPA with some ex-supplier, but they are not in a position to supply from June 21 due to various reasons. Again, the cost has gone up from current 7.41 to 8.37. So there is an increase in the unit price. This was the situation. Then as a green energy consumption, in the month of May, we had an agreement with the BESCOM on the discounted energy rated scheme. This is applicable for Karnataka, but I am not sure about other state, because state to state it varies. So we have gone with a DE or a scheme with some 50 paisa additional for the green energy power, whatever it may be. And currently for the last year, including August, we are with 100% green, and we have made the agreement for this entire financial year, and this we are sustaining. So this is one factor externally what we are doing with, along with the government policies. Apart from that, of course, there is a cost saving, which also every companies need to see, not only CO2, but also how the cost reduction in terms of supply area. We have to see each area how we are going to get benefit. But future thinking way is, we will be in line with the government policies, and also group captive power agreement in line with the government policies based upon the guidelines what they give, so that we can reduce cost, plus also we can meet CO2 reduction. So this is on the supply portion, where The key is focus on green energy, either by PPA with external vendor or by installing the rooftop solar, again based upon the government policies. Next, we'll go to the consumption. Consumption is what we consume as a factory based upon the equipment that we use. Consumption viewpoint is energy reduction through reducing muda, means wastage at the usage area by using 7 energy reduction innovation viewpoint, which I will explain in the coming slide. There are 4 steps involved. First is ABC identification, classification of the machine. I will explain what is ABC. Midori generation is idea generation, implementing the ideas as a Kaizen, and sustaining through a management review. The key point is ABC machine classification activity to promote energy reduction by member involvement is important, not by maintenance person or utility person. It should be a total involvement where an organization is being made across all the departments. This is related to consumption. There are 7 viewpoints. First is fixed to variable. You can see the demand is there, the supply is there. The supply is always on, even though the demand increases like this. Means this portion is an energy loss. But how to have fixed to variable is your demand is like this and supply also should be like this, so that you are changing from fixed to variable. So this is one of the viewpoint in consumption factor. Second is stop over capacity. Very simple, like I'll be now I am alone in the office. There are another 100 lights around there, but I switch off only 1 light above me so that the other lights are switched off. So that here also it's called as stop over capacity. Next is reduce leak and loss. The leak may be anything. It may be a power leak or air leaks. Example here, if you see the joints are like this, but if you reduce the length, you can have an improvement like this to reduce the air loss or whatever it may be. And reuse the waste energy. Like when you do a like the car or ED tank procedures, how you are through an economizer, you are reusing the waste energy. Whatever the waste you generate, it may be a heat energy, how you are going to reuse it in your line. That is a key point, so that your waste energy can be reused. Then change equipment low to high efficiency. In case currently we have there are many motors, IE2, IE3, IE4, IE5, it has come now. But we need to appropriately use for where what type of motor need to be used, so that we can go for energy efficient motors. And stable usage. Wherever your process, where you have peak loads like this, if we have a peak load, then it has a sustenance. But how to attack the peak load, how to cut the peak load and bring to a optimization level, that should be the key point in the process or anywhere, so that there can be energy reduction. And change energy source, pneumatics to electric. Any company, air compressor is the highest power guzzler. So how to change the pneumatic to electric should be thought of in the area of applications, wherever it may be. So these are the 7 viewpoints with regard to consumption. So this viewpoint is very key for any auditor, so that this should go into the brain of the people and should get registered when they do the audit, so that they can find many NG points or not good points to have an action plan for future. So based on this, what I want to explain is about ABC classification. Purpose is use ABC concept to reduce energy consumption. Basically what I told, fixed to variable. That is the key point here. For that, this is an example. Identify the current situation, that is ABC classification of the machine. Visualization, that is through layout map with a tag, improvement on the viewpoint, and audit summary report. What is ABC? This is the you can see the production. This is the production line where you have a production, then you have a lunch, then some production, then some shift change like this. This is a pattern we can call. This is a pattern. But when you see as A is in line with the pattern, which is supposed to be the best condition, where you can have an energy in line with the demand. But B, if you see, there is a production, but there is on holiday, it is off, and then again it gets on. So here, this we call as B classification, B type equipments. C is continuous running, even on holidays. Even if there is a COVID lockout, the such equipments or motors will be running irrespective of anything. So we call as A, B, C. So how to bring C to B or B to A should be the viewpoint thinking. So this we need to adapt on the shop floor for equipments. So please have the overall graph on ABC classification and try to achieve with the Kaizen and reach to either to A or either to B based upon the equipments. So ABC classification activity to promote energy reduction by member involvement. So when we are doing this activity, the end user, even an operator, should be involved so that he also knows what is A, B, C, and he can give an Kaizen idea for improvement. And this is just an example of the shop floor, like how we have identified A, B, C at a different group members, and based upon the viewpoint what I explained, and sum it up, how many is A, how many B, and how many is C. So based upon this NG, we should identify and how we are going to convert C to B or A with some improvement result and show as a CO2 reduction in terms of tons of CO2 and also the cost. This is supposed to be the expected result based upon the activity. So this is called as energy obaya, where each data need to be monitored, each need to be evaluated in terms of numbers, then cost, then reduce how much it is going to happen in terms of tons of CO2 first, then cost. These are the few examples which I would like to show, which has been implemented in the shop, like cooling tower operation time management by converting B to A. So usually cooling tower will run on almost every day, especially the motor I am telling, not the fan, because most of the fan, it will be based upon the temperature, it will be set. But as a motor, cooling tower motor for the water circulation, it will be continuously on unless and until the plant is switched off or shut down. So it is means on the weekdays it will be on and on the holidays it will be off. So the viewpoint is how to convert B to A. Target power consumption reduction in cooling tower by closing the operation during lunch time. So this is the operation time and how we are going to close it in lunch time. This is by installing a simple timer. So based upon this, this is the savings as a company based upon the cooling tower. This will be varying based upon the different companies, because the size of the cooling tower, it varies, or the pump, it varies, number of cooling towers, number of pumps. So this is one example for the consumption what I have explained. Next is a one more small viewpoint. Fan in break area operation time management by converting B to A. Power consumption reduction by installing calendar timer. So these fans, example, during break times, it will be switched on automatically when the operator comes for a tea or whatever it may be. And so much is the energy consumption per year. But after condition is we use a real-time timer so that the energy consumption is so much, and the balance reduction, there's a difference of this is so much kilowatt per year, and the CO2 emission reduces so much tons per year, and cost every is 0.046 million per year. It may be small in some cases, it may be big in some cases, but tons of CO2 reduction is the key point. And the viewpoint understanding is very important. So like this small Kaizens can be done in the shop floor based upon the applications. Next, this is in the process. This is a conveyor where a part is being transferred by an electric conveyor. So any electric conveyor, one is on the safety. Yes, there are rotating equipments where many safety incidences happen globally. But how to avoid an electric conveyor? We have gone with a Karakuri conveyor, where automatically by gravity the parts comes and the operator picks up. So that one is energy saved. Second is safety is also ensured. So much tons of CO2 what was consumed, sorry, energy what was consumed per year is been reduced to zero because of the gravity flow. So it also have a reduction in tons of CO2. These are just a few examples to have a viewpoint for the members so that they can implement in their shop floor based upon their process or their applications. Next, let us go to the conversion thinking way. Conversion is focusing more on the utilities. It may be air compressor, chiller, that diesel or LPG, whatever we use. So there are again 4 steps involved. As I said, it is similar to consumption, equipment energy supply layout and tagging of the machine, idea generation, Kaizen implementation, and sustenance. There are 6 viewpoints in conversion. First is too much supply to matching demand. You can see the supply is like this, but my demand is like this. How you are going to balance this is the key. So this viewpoint is most important. So everybody should meet to this balancing viewpoint, that is too much supply to matching demand. Next is reduce leak and loss. This is applicable for both consumption and conversion. Again, it shows about the air leaks in the hoses where we cannot visualize, but we can hear on holidays. So that need to be arrested. And also like loss of insulators, that is on the electrical side. Then reuse of waste energy. Example, any burner, it may be an LPG in the paint shop, what we use, how it is get exhausted to the atmosphere, how it is being reused and used for the process. Any waste energy, how we can reuse, that need to be thought of. Stable supply, like we have one machine running and one is stopped for a with a accumulator or a receiver tank, whatever you call as an air compressor, and 3 more equipment running is 2 stop for a shop T or shop or whatever you call. But how we are going to optimize this 4 running to 3 and use it for the process and have even a small baby air compressor for a smaller application at the end area. So this is how we need to optimize as a stable supply. Use of high energy, high efficiency supply energy. Now many equipments, if you take as an air compressor, there are coming at 95, 92 or 70%, like what we would have purchased in the start of plant with the 90, 96 or 97 when the plant is established. Many old compressors still running, but the energy efficient is not good. So it may be working at 70% efficiency. How we are going to invest on new energy efficient air compressor or equipments, or it may be not only air compressor, any equipments, so that the low efficiency equipment can be switched off. So go to switch over to high efficiency equipments. Next is change energy source, like air cooled chiller to water cooled chiller. So this 6th viewpoint is very important for conversion. So I told 7 viewpoint in consumption and the 6th viewpoint in conversion. This is key point that everybody should take into mind when they do the audit in the shop floor with respect to conversion. This is very simple example, compressed air management system for energy reduction. The major issues what we face in air compressor management system is basically no data available for compressor efficiency. Nobody will monitor the CFM on daily basis, or unless and until somebody pump in by an external auditor, do the energy audit, they will measure what is the supply CFM, what is the demand CFM. So usually no data will be available. Non-standardization of compressor standard by management. No system for understanding optimum pressure equipment. Too much conversion, huge loss in the system. This is how a compressor system is established, and the supply pressure will be like a 6.5 bar with the 4 bar at and 5.5 bar at a different area of applications. And here also we have a different applications that I may be using an what you call air booster to again build up to use for certain equipments. So we are not optimizing the air pressure. So this is one big point. So how to improve? Example, we have a 90, 87, 95, 92 percentage. How you are going to have a standby of low efficiency compressor? Use high efficiency compressor, generate with a example X bar or 4.5 bar, supply with reduced to 4 bar, and use for a different equipment. And if any small equipments need a higher pressure, go with the local air booster. So that only for that equipment you need a higher efficiency, higher operating pressure, so that your load on the main compressor comes down. So this will have a big energy savings, and we have experience of 16% of energy savings in air compressors. So usually when a plant expands at different locations, different compressors will be laid, but how you are going to centralize it and make a main header and sub headers so that we can optimize on this operating pressure and supply pressure, so that there will be a big energy savings apart from the air leaks. Then use high efficiency unit supply pressure. That is, again, this is on and this is on and this comes as a standby. Here, change of air tools. For example, we have a pneumatic air tools converted to electric air tools. No need pneumatic air tools because it also have either air leaks, lot of consumables. You need to have a filter or FRL in some cases, but electric tools doesn't have that, only just a battery charging or a power supply. So this also have a very big impact on the energy saving. And if you go with the cylinders, any cylinders, it has its own lifetime. Any cylinders leak can be visualized through the silencers on the holidays. So this also have a very big impact on air loss or energy loss and convert into electric equipments. This is how the conversion factor need to be checked and adopted in the shop floor for modifications with little investment or major investment. But we need to see the ROI, return on investment. Anything below 2 years, that is the best, but in some cases it goes up to 5 years. But better to have a low investment but higher returns. And this is few example, like a Viewpoint is matching demand by setting temperature of outlet water chiller, energy consumption reduction by setting temperature of outlet water chiller. For example, we have a chiller with inlet water and outlet water 16 degree. Now that 16 is increased to 18 degree. The 2 degree difference, of course, it calls for energy reduction and CO2 reduction and cost reduction. So this need to be done in congruence with the process. We also see at the end of the day, either my part quality is okay. So we also always believe not only on the power reduction, quality is also key point, safety is also key point in wherever the aspects comes. So qualities need to be considered in such cases where it also have an impact on part quality when we do such type of changes. Next is matching demand by setting header balancing wall adjustment, resulting in demand-based supply through VFD in cooling tower motor of plant 1. Here the target is energy consumption reduction by meeting or setting supply versus demand. For example, here with so much gallons per minute, 178.4, it is operating now. It is with 70 gallons per minute, that is through VFD and also line balancing, that is a valve balancing. So there's a big reduction. This also have energy reduction. This is again comes as an example for conversion factor. These are all the examples already done in the shop floor, which we are showing you. Next is switching of air pressure to independent machine while machine not in operation or no production. Energy consumption reduction by adding pneumatic operated solenoid valve for each machine to shut down during machine stop. Most of the times when the machine is stopped, the air line is on up to the end usage point. So when you press the emergency stop, usually our rule is we press the emergency stop while stop of operation. When we press the emergency stop, the solenoid valve means activated and the entire line up to the end use point is cut off. Certain processes need air supply always. Such process no need to touch because it also affects the quality. But wherever no need air when no operation, please adopt such type of system where you can see what is the loading earlier and what is the unloading before and after, like 25 times 20 and 16 to 44. So this is how we need to see how we can save in terms of conversion factor. This is the savings in terms of pence and in terms of rupees. This is one example. And next comes the evaluation of the result. Whatever I showed is an example on consumption and conversion, but evaluation is based upon the GEMBA, whatever we display in the shop floor. We need to have the data, and that should be audited by plant head, and analysis that should be reviewed by plant head, and the KPI confirmation. Everywhere there's a target being set. Are we within the target or away from the target? And report to top management, review and get their feedback or suggestions for improvements. And when we have done some improvement activity, we need to have a standardization also. So review your policy. For example, if I set for 2%, if you could able to perform better, review your policy to have much more stringent targets to have further actions in the shop floor on CO2 reduction activity. So both environment policy and CO2 reduction policy in particular need to be reviewed or revised based upon the last year actuals that is been achieved. And we also need to set a challenge for the target with some percentage of energy reduction, and accordingly the budget also need to be planned. Anything, most of the activities like we call low hanging fruits can be achieved without any investment, but in energy almost few areas except supply, where it all government policies or OPEX or whatever the model we go, whatever we see as a consumption and conversion factors, 70% goes with some investment plan. It may be a small, it may be a big. So that need to be planned as a budget, and detailed activity action plan need to be derived and made, and that need to be followed for the next financial years. So based on this, I request the team to make an internal schedule towards the energy reduction activity with the support of top management. Any activity should be driven by top management, not from bottom to top, top to bottom, so that the support will be there and rigorous follow-up will be there. And every activity should be connected to your own corporate companies and government policies, so that the drive will be there. Otherwise, a department like maintenance or utility doing and showing something is not going to sustain for a long way. It is going to be entire company involvement. This is the request. And few takeaways that need to be expected is the need to align with government policies, corporate policies towards CO2 reduction, and main focus on life cycles zero CO2. And I request to utilize the session to improve on CO2 reduction viewpoint, and let's work together towards creating a clean edge for the next generation. So this ends my session, and if any question answers, please ask. And I have covered mainly on consumption and conversion with a few examples. This is just an example. There are a long way to go for each companies. Maybe they would have gone with more digitalization, but we are in the process of going for digitalization. Is based upon the whatever the paperwork what we do as a OBAYA management. We call OBAYA is displaying all the data in place and analyzing in terms of units per kg. Since we are an injection molding facility, we monitor units per kg across each injection molding machine, whether it is as per the target or against the target. So like that, each companies can have their own target in place, and use this concept, like this concept of supply, conversion, consumption, with the 7 ERA viewpoint on consumption and 6 ERA viewpoint on conversion, and use this, apply this in your shop floor, so that you can have a real benefit and real fruit. And this is my experience and our experience at TGS Science. Thank you, sir. Thank you all for your patience in listening this small session, which I want to share it based upon our experience. And thanks to IIPE team for organizing this seminar And thank you one and all. And if any questions, please put forth to the table. I am ready to answer for it. Thank you.
I have a question.